What's up, everybody? So I get to film a quick lesson for you here, which I'm sure is just going to add to all the awkward teacher videos that you're going to be watching or that you've already watched. I think I've heard some teachers have already made them. So yeah, we're going to try and make this work. I think, if you do the math, there's only going to be like 4 or 5 of these until the end of the year. Shouldn't be that big of a deal. I'll try and edit this up and put some background music and be my usual silly, weird self. For the most part, you won't be looking at me. You'll probably be looking down at the paper that I'm working on while I'm taking you through some practice problems. That's about it. Hope you're all doing well. I certainly do miss the routine of coming to school every day and seeing you guys, and I'm sure actually you guys do too. We'll get it done. Here's video number 1. All right, Algebra, we are going to do some working with polynomials here. I know we left off working with radicals and square roots and things like that. It just seems to me like this is the easiest thing to do. So we're gonna work with polynomials. Today we're gonna add and subtract them. You're gonna have to remember what like terms are. This is a definition that you should have in your notes. I'm not sure if I gave it to you this year, but for sure it's something that we've discussed before. So a polynomial is a term or the sum or difference of 2 or more terms. When working with polynomials, a term can be defined as a number, a variable, or the product of a number and one or more variables. Here are some types of polynomials you should know. Monomial, meaning only one term. 3c is a monomial. 5y(z) to the third is a monomial. All right. Now, why are these monomials? Because nothing is being added or subtracted. It's just one term. Now, a binomial has 2 unlike terms. For example, x plus 1. This right here would be called a binomial because it's got 2 terms. X is a term and 1 is a term. And this guy right here, 3m to the 4th minus 2m. That's a binomial because it's got 2 terms. Anytime you see the addition or subtraction, those are separating terms. 3m to the 4th is a term, 2m is a term. And these are not like terms because the exponents are different on the m, all right? This exponent is 4, this exponent is not written, so it's a 1, and they're not the same. They would both have to be the same, all right? Remember, like terms have to have the same exact variable factors raised to the same exact exponents. And it follows here a trinomial is gonna have 3 unlike terms. I don't know why I just said that like that. 3, but whatever. 4x squared minus 3x plus 1. 1, 2, 3 terms. 7a squared b squared minus 3a squared plus 1. 1, 2, 3 terms. To add or subtract polynomials, you combine like terms. They have this trinomial being added to that trinomial. Now, the parentheses here are meaningless when it's addition between them, okay? Because the addition doesn't change anything. In a moment, when we do subtraction, we will see how the parentheses are most certainly not meaningless. But in this one, when they're adding, the parentheses are meaningless. So all we have to do here is identify like terms and combine them. We have a 6x squared. Do we have any other x squared terms here? Yes, we do, right there. So we have a 6x squared, and we are adding to it a 7x squared. That is going to be 13x squared. And now we've taken care of those two. Negative 3x, negative 3x. If I add a negative 3 to a negative 3, I will get a negative 6x. And now I've combined those like terms. Constants, numbers, are like terms. I have a 9 plus a 5. That's going to give me a 14. And now I've taken care of those. This guy right here has no friends. There were no other x cubed terms. 9x cubed just stays 9x cubed. And the final answer here when we add these polynomials is 9x cubed plus 13x squared minus 6x plus 14. This is a 4-term polynomial. 1, 2, 3, 4 terms. Now, subtracting. Now the parentheses are not meaningless because everything in these parentheses are being subtracted. It's like you have to distribute the subtraction. You could either remember that or you could actually rewrite it. You could rewrite the end of this expression as minus n to the 7th minus 3n cubed. Minus a minus is plus 6n minus 12. And now you could just do the same thing here that we did in the addition one, all right? You can forget all of this now, and now you can just combine your like terms. So we have a 7n to the 7th and a negative n to the 7th. 7 minus 1 is 6n to the 7th. And that's where that came from. 7n to the 7th. There you go. 9n cubed minus 3n cubed. 9 minus 3. They're like terms. 9 minus 3 is 6n cubed. And now we've taken care of those guys. Oops, sorry. Those guys. Crossed out the wrong one. Sorry about that. Negative 6n plus 6n. When you take a negative 6n and you add it to a 6n, you get 0. 0.
0.
Negative 6 minus 12 is negative 18. And when you combine all the like terms here, that's your final answer. 6n to the 7th plus 6n cubed minus 18. Apologies for crossing off the wrong one there. That might have confused you there in the middle steps, but hopefully you can follow through and see what happened. You could also pause this video and read through the work here and see, there's the 0 they got and everything else that they did in their steps. I think we'll just leave it at that for now. I'll put up some work and these 2 example problems for you, and see you later.